Compound components. Hey everybody, this is Ben Finkel, and in this nugget, we're going to take everything that we've learned so far and kind of build it into a fully fleshed out React component that's going to do a cool search. Before we do that though, we're going to talk a little bit about the life cycle of components so that we can understand how different events are triggered automatically, both on our parent as well as our child components inside of a compound component. You're not going to be able to build too complex of a React component or application without getting into this idea of, well, what I call compound components. And by compound components, I mean components that are not one simple React component, but actually multiple components that are organized into a parent-child hierarchical relationship. And this is important because we really need to break up our user interface into these small, distinct, resolute objects in order to help promote separation of concerns and proper code management, unit testing, all those things, but also to make our code simply easier to understand and easier to read. Now, before we get into components, we really have to talk about something called the component lifecycle inside of React. And the lifecycle refers to the fact that components, well, they're born, they live, they breathe, and then they die. So components are coming and going, and different things happen absolutely within the life cycle, the lifespan of a component, and we can kind of capture those points. We can peek in, take a look at our component at various points during its life cycle, and perform operations that might need to be performed. Let me explain a little bit further what I mean here. The first three lifecycle methods, or lifecycle events that I'll talk about, are component will mount, component did mount, and component will unmount. They're fairly descriptive, and you can probably start to figure out what these are just by looking at them. So component will mount is a function that is automatically fired right before the component is rendered into the virtual DOM. So you can go ahead and grab a hold of that component and perform some operation if you need to before it's rendered. You might need to, say, look at the properties that have been passed into this component and update its state accordingly. And if you do that and you call this .setState, it's important to note that that doesn't add another render cycle or another render method into the whole process. The component React will recognize that you've updated the state inside of this function, and it will still only render a single time. Component did mount, just like that, happens after the component has been rendered to the virtual DOM. Component did mount is the after effect. And then component will mount, or component will unmount, is what gets fired right before the component is removed or deleted from the screen. And you might think that you're not going to be doing a whole lot of that, but if you get a really complicated web page, a really complicated application, you might need to clean up and remove React components from the page just to manage your performance. So you can capture any of these lifecycle events simply by declaring a function inside of your component with this name, component will mount, component did mount, etc. And that event will fire automatically for you at these various points in time. Now it's important to note that these are one-time fire only events. These get fired, well, these top two right at the beginning when the component is initially being created, initially being rendered. After that, they don't fire. If they're just being updated because of a set state operation, a re-render process, these component will mount or did mount operations are not firing. The next event that I want to talk about is component will receive props. And just like that sounds like, this is going to fire whenever new properties are being sent into a component. So this is the event that's getting fired over and over and over during the life cycle of a component. You might very well be updating the properties from the parent of this component over and over and over during the life cycle of that component. If you need to inject some code or some interaction in between that event before this component is re-rendered, then you can do that. You can simply capture this event, component will receive props, and again, maybe you want to update the state before that actually happens. And then lastly, the last three events that I want to talk about are should component update, component will update, and component did update. So these are the types of events that, again, can fire routinely over and over during the life cycle of your component. Your component may update many times. And the first one, should component update, I think is the most interesting. Should component update is a function that you can interact with, you can intercept, and you can actually return a false from that function if you implement it. And if you return a false from that function, the rest of the rendering process doesn't happen. The component is not rendering. So you can actually interrupt that render process. Some reasons that you might do that. Well, you might know without a doubt that it doesn't need to be re-rendered, and you want to save some cycles. You don't want React to have to go through the process of figuring that out itself. You're able to very quickly look and know that you don't want to do the render. Or maybe you've got a whole bunch of updates coming in at the same time, and you want to delay rendering until all those updates are finished. So instead of React having to re-render 10 or 15 or 20 times and cycling through 10 or 15 or 20 times, well, you're just going to stop and wait until all those updates are complete, and then you can do one single re-render at the end. Because remember, rendering to the DOM is the most expensive part of anything that we're doing here. So should component update, I think, is really, really cool. If you don't interrupt it, if you don't interact with it, it always by default returns a true. Obviously, you can get into real trouble if you use should component update in the wrong way, so tread carefully there, but it's a neat lifecycle method to interact with. Component will update and component did update are similar to the will mount and will unmount, or sorry, will mount and did mount functions over here. They will fire right before the component updates and right after the component updates so that you can perform any pre or post processing tasks that you might need to perform. All of this is described in way more depth and really I think very well in the official documentation here at the GitHub page. It really explains each of these lifecycle methods, when you would use them and when you would avoid using them and for what purpose. Now, a couple of things that I think are really important to understand as we talk about compound components here and get into actually building our component is A, I've mentioned this before, but this is really important. Children get their props from their parent but manage their own state. So what do I mean by that? Well, the props that a child component has are handed down from it, from on high, as I say. They are given to that item and they're meant to be immutable. A item or a React component should not update its own properties. It should only receive updated properties from its parent. Now, its parent may very well be the DOM. I mean, this may be the top level component, and those properties are coming in from the attributes on the element that are in the React DOM.render. That's still its parent, so it's always getting its properties from its parent. On the flip side, its state should be managed by the component itself. It's kind of like state is private and properties are public, although that's a loose analogy. Don't hold to that too strictly. But the idea here is that you update your own state, you manage your own state, but you receive your properties from someone else. And keeping this in mind and keeping that organizational structure in mind is going to help you to write really clean React components. Another important thing to note about these lifecycle methods is the order in which they fire. And they basically fire top-down before render and bottom-up after render. What do we mean by that? Well, I mean that the component will mount is going to fire on a parent component before it fires on a child component, which will fire before a child component of that. Those are all the component will mount. That happens before render, so it's top down prior to rendering. Once we've rendered, component did mount is going to fire down here first and then move up the chain. So after render, component did mount is going to fire bottom up. It's going to fire on the lowest child first, and then up the chain it will go. So it's important to remember when you're thinking about what order these lifecycle events are going to fire from when you have a compound component, that they're going to follow that top down prior to render, bottom up after render. So now let's talk about the component that we actually want to build. It's pretty cool. What we're going to build over the next couple of minutes here is a really simple search box that's going to filter this list of items live really quickly as you type it in. So you type in a letter, it's going to quick search down, filter that list to just items that include that letter. It's really easy to do with React, and it shows off a lot of these neat concepts that we've just been talking about. Now, in order to go from a design, you can imagine if I sketch this out, into an actual React component, there's a couple of things that we want to do, a sort of a preparation step that we want to go through. And the first thing we want to do is we want to identify our most resolute stateless components. And what do I mean by that? Well, we don't want this whole thing to be one single React component, although we certainly could do that. Rather, we want to take advantage of React and the parent-child relationship and the ability to hand down props and update state accordingly. And we want to figure out what our individual components are and which are the stateless components. We want as many stateless components in our React as we can. We really want to have state living in as few places as possible because state is the difficult thing to manage. That's where the complication of user interface is coming in, at least from the programmatic standpoint. So looking at this, I'm going to break this down. I'm going to say, well, okay, we've got the whole component here, my filtered list or whatever it's called, and then I've got this search box up here, and I've got this list of things down here. Okay, this is cool, this is good, and then each item in here is just a text list of something. Well, I'm going to call those my most resolute stateless components. I'm going to call those my list items, to steal a word right from HTML. So my list items are completely stateless because they're just delivering text. That's all they have to do, is spit out whatever the value of their particular text property is. And then the rest of it is where the state is going to live. So I'm going to have this search box controlling this list of items. I'm actually going to use an unordered list, a UL component or a UL element on HTML, and that's where my state is going to live. Now, if I'm really getting advanced, I can also look at this and I can identify two background data structures really that I'm going to need. I'm going to need my initial list of items. Why is that? Well, because this list is going to be static right here. That's my initial list of items. It came down from my server, which pulled it out maybe out of a database. I don't know. But the simple fact of the matter is whenever I pull a search, I want to search that list. Whenever the user erases everything in the search box, I want to return it to that specific individual list. And I'm also going to need my list of filtered items. That is the list of items that match. I cannot write for the life of me here. The list of items that match my search results. So this is my unchanging initial list of items. This is my changing or updating list of filtered items. And that's a clue there. That's why I said changing and unchanging. That's going to help us understand how to use them. But let's get right into the code and see how we build this, and you'll understand how it all comes together. First of all, here is my finished product. You can check out this JSFiddle URL right at the top, and you can see how it works. I just type a letter, and it automatically filters down to whatever I've typed in, at least whatever matches what I've typed in. So here I've typed in the letter G, and every item that has a letter G in it shows up in my list. When I erase everything, it goes back to the full default list. But I don't want to show you the finished product. I want to show you how we build it out. So I'm going to start here from this fiddle, and I really encourage you to load it up and follow along as I do this. Let me talk about what I've got in here initially. So first of all, I've got a structure of items just inside of my JavaScript. This is just the list of items that, again, maybe it came down from a database search on the server. It doesn't really matter. I'm pretending that this is the list, the total list of items that are going to be inside of my searchable list box. That's all I've got. Then I've got two components. Right here is the top level component, my parent component. I'm calling it filtered list. And if I scroll down a little bit here, you can see I've got a list item down here, and this is just going to be my individual list item. Notice that in the render for my top level parent component, I've got a div and then an input. That's for my search box, of course. And then I just have a list. And the list is going to be this item here, which is going to return that array of results from my search. Then lastly, I just have my react-dom.render filtered list. So all I need to do is call react-dom.render the parent component. The parent component is going to render the list child component, and the list child component is going to render each individual stateless item inside of that list. So first things first, I need to get my list of initial items into my filtered list and have that render down in the list component. Remember I said that initial list is unchanging, right? This is the top level sort of baseline list, unfiltered, etc. The reason I call it that means that from the perspective of filtered list, it doesn't change. Well, that means this should be a property, and that's exactly what I'm going to do here. I'm just going to come down to my filter list, and I'm going to say initial items, spell it right, equals, and I'm going to press in my items. I believe I called that structure. Yeah, my items. So that's all I'm going to do right there, is say the initial items are equal to my items. So this will create an object inside of this.props called initial items, and it will be populated with the structure of my items. Up here, these are my items. That's my initial list. Great. Now I want to render that into my actual element. Well, initially, that's my list of items, but really that ought to be the result of my search is what I'm going to render. And the result of my search can change depending on what's been typed into the input box. That means that I've got a state called, well, I just called it items. And that's the thing, that's the object or the structure that I'm going to use to store the result of my search. I use the getInitialState method in order to create a state with an item called items in it, or an object called items in it. And now I want to populate items, well, initially just with the basic list. I mean, that's all I want to do to start, is I just want to put the whole list right in there so that before the user even does anything, they can see that list displayed on the screen and choose what they want to start typing. This is a wonderful use case for component will mount. Check it out. By coming in here and putting my component will mount function, by defining it on my filtered list, I know that the first time this is initially rendered, this is going to get fired off. And I can call this.setState equals items this.props.initialItems.items. Think about for a second what I'm doing here. I am updating the state, and I'm setting this item structure that I created right here equal to this.props.initialItems.items. Items are these things right here, and initial items is that property I just added down on my react-dom.render. This means that now, when my component mounts, I'm going to get my state set initially to the initial items. That's perfect. So if I go ahead and run this code, well, I don't get anything yet. And the reason why not ought to be obvious when we look at it for a second, and that's because nothing happens down here where I render my list. So now my filtered list, my parent component, has a state of items that represent, well, the current list of items that we want to render. How do we get that down to our list component? That's right, we do it with another property. So from the perspective of filtered list, the parent component, this is a state. This is a changeable, mutable list that the user can update. So the state is being stored inside a filtered list. But from the perspective of that child, those guys are stateless. We just want to list out whatever the current state is of our parent. So we're going to create another property here on our list object, and we'll just call it items, how about? And we will set it equal to this.state.items. So now our list component has a property with a list of the items that we want to render. This means that we can handle all of our filtering up in the filtered component or the filtered list component, and then we just pass down, we just update this state with the appropriate list of things to render, and that'll get rendered down inside of our child. So our child, I'm just going to cut and paste some code in here for how we render this. Taking advantage of the JavaScript mapping function, you can see here that I simply map through, I iterate through each item in the property, this.props.items, which came from right here, and I create an li item for it with a key and an item in the text inside of the property value for it. So very, very simply, I just create a UL that lists out each item that is in the current state of my items inside of my filtered list. So if we back up and go ahead and run this now, we get, boom, there's my list. There's my search box being rendered by this input right here. I'm actually going to draw on the screen to show this. So there is my search box, and it is rendering that search box right there. And then here is my list, which is rendering a UL of all of the items inside of my initial list, inside of my initial state. So we're halfway there already. I mean, this is great. Using my CSS, it looks pretty good. Uh-oh, wait a second. It doesn't work. Well, of course it doesn't work. We're not doing any of the filtering functionality yet. So let's plug that in, and we'll see how this all comes together. So let's ask the question, how do we want a change to be triggered? What should cause this list to shorten up? And, well, the answer is whenever we type anything into the input box. On change on our input box. We know all about events on change inside of an input box. I'm going to come over here to my input box. And I'm going to say on change equals well, what's it going to equal? I'm going to have to come up with a function that filters down the current list. So I'm just going to call it filter this list. Oop, that's, you know what, that's a little long. I'll just call it filter list instead. Yeah, it makes it fit on the screen a little bit nicer there. So on change, when I change the search text box, I want to filter the list. Let's go ahead and make that function so that it updates the state and changes the list to represent whatever matches our search. I just went ahead and pasted the initial piece of code in here called filter list. You can see exactly how it's going to work. It's going to take, of course, my event object. That's the synthetic React event object that gets passed into this function. And what I do is I get a hold of an updated list, and I use the .filter JavaScript function in order to, well, to return items that match our event.target.value. Event.target.value is the value of the search input box. If you understand JavaScript events, that should be fairly obvious. If you don't, read up on them. You need to sort of understand how JavaScript works in order to use React. It is very reliant on JavaScript. But the event.target is the item that is causing the event, and of course the .value is the value of that element or that object that caused the event. There's one last thing that we need to do here. Now that we have updated list populated with the search results, we need to call, that's right, this.set state. Why do we need to do that? We need to tell React to re-render this with the new list, and the best way to do that is to change the state with this.set state. What do I need to change this.set state to? I need to say the items are now equal to updated list. Go ahead and put my semicolon on there. And at this point, I've now got an event that's triggered when I type into the search box. It's going to update that list, cause a re-render. The re-render is going to update the state of my items. Better make it plural if it's going to work. And again, those items are being passed down as a property into my list object. I believe that if I run this now and type in my W, Wow, there it is. So super quick, super easy. We now have a searchable list box based on properties and state and parent components and child components. And we're using the getInitialState method. We're using the component will mount lifecycle method to create a really clean, easy, and simple compound component in React.js. So that concludes this nugget on compound components in React.js. To recap, we talked about the life cycle events of components. Components will mount, did mount, should component update, component did update, etc. And how these interact, how these life cycle events fire based on parent-child relationships between our components. Then we took a look at how we can actually build out a rather complex composite compound component with a parent item and a child item, some stateless components in it, as well as some stateful components in order to properly organize and create a nice, fast React.js component. I hope this has been informative for you. I'd like to thank you for viewing.